Good day, friends. Today we continue our lectures on the concepts of objects and classes. We're going to begin with some short notes, document that we have here. And before I begin, I want to appreciate the people that have subscribed so far. If there is any comment, please drop it below. I will try and address that. Please, I will now continue to drop the PDF documents in the link below as well. Now let's focus on today's study. Today we are talking about objects and classes. Now let's go. Let me show you the few documents that we're having now. What is it? We talk about objects. Anything around you is object. They have both state and behavior. You as an individual, you are an object. You have a state and behavior. What do we mean by the state? It can also represent the feeds. The feeds, those attributes that you have, they are also represented as attributes. The state represents the attributes, the behavior represent the functions. So what you can do and what you cannot, what are those things that can change you? Those are the behaviors. And the things that cannot change in you, that your complexions, the number of legs that you have, that by default, the number of legs you're supposed to have 2 as a human being, the number of holes, your nose is 1 and 2 ears, your eyes, 2 eyes. So those things that cannot change about you, they represent the state of an object. So what are those things that can change about you? You speak, the way you speak is different from other people. The way you walk is different from other people. You also develop a system to determine how people walk. How you do walk from your children walk. The way you walk is different from the way your wife walk or the way your friends walk. Now let's move into classes. Class is a blueprint of an object. That means it's a template for creating an object. What is a template for creating an object? So from that object, we said earlier that object has a state and behavior. Now, what do they mean by the state? The states are what they cannot change, as we said earlier, or state are what they cannot change, yes, and behavior are what that changes. The state here, for example, you. Now, you are an object. You have attributes. You have attributes and methods. So we represent the state by the word attributes. You can also be called data members of it. We're going to be seeing them in the demonstration of the code. So then we also have the methods. So we represent your method, we represent your behavior in form of methods. Then we also have constructor. This constructor enables us to initialize object of that class. Maybe we want to take in default constructor or different default information. We also pass in information to the user. Don't be disturbed by the word constructor. Enable us to construct from the word. Enable us also have destructor as well. Destructor as well, though they are handled automatically to clean up resources. Enable to clean up resources in case you can also clean it up by yourself. Let's go ahead and let's see a sample of a class. If you want to create a class, you just put the class name or the class modifier. You call it access specifier, or this is the data type. Sorry, this is the data type. This is data type. Sorry, this is data type, and this is the name. By default, as a common use in practice, you capitalize a class name, capitalize it. So you can give it any name. Then we end it here. Don't forget to end it here with what? Semicolon. Unlike programming languages like Java and C#, you don't need to put semicolon at the end here. But in C++, we need to put semicolon. So you ask me, why are we putting semicolon? That is a compiler understand it. Now let's create, for example, let's create a class called vehicle class. Vehicle is an object, right? Vehicle has a name, right? and they have a type of a vehicle. Now we also call it, it's an attribute. Here is it here. Then we have it here this way. Then we have these are constructor here. The constructor take the names of the same class. Just put the name here and put it here. So now what we tell this constructor is not taking in any parameter. We don't pass anything here within this called inside this parentheses. Unlike this one that we pass in parameter here. So that means even though we declare a class like this one and we don't create a constructor and we now create some other variables and other functions, by default the compiler will introduce a default constructor that is called by itself, just like this one, but without any information, without any body inside, no body inside this, inside this scope. This is the beginning of this scope and this is the end of this scope. This is the beginning here, this is the end here. Then we now create another constructor. You can have more than one constructor at a time, but they must be different because this program is case sensitive. One, the number of data signature here number of parameters specified must be different, or even the data type must be different. It must be different. Don't worry about this. We're just trying to initialize the value here. Don't try. Just try to assign. Okay, this by the time the user and by the time we call this one, just assign the value to the what to this. I'm going to demonstrate to this. Assign the value and move it to the what, or move the value of n and store it inside name. Move the value of t and store it inside what, and store inside type here. So that just it. So we're going to be seeing let's display the information here of what the user enters. Now this is how we destroy. We want to do a case. You want to just demonstrate the structure. Just put your T sign. This is a T sign here in front of the same name. You can see this constructor is different from function. You can see that we don't put any modifier, like maybe it's a void, it's returning something else, but only what was put was what is public. It's under access specifier that this is public, or else if it's not public, we won't be able to access it in our main file here. Alright, in our main file, we won't be able to access it here. Now let's go ahead. Please, if I'm too fast, please you can pause the video. Here's run it again, back again. Now we're still in the same class. Then we have this. I think this is an error here. Please, this parenthesis close bracket here is an error here. I will remove it. We also have something here. Then we now have functions here. We create a behavior. We have this our data member. We have private of string name and type of the variable. We create two constructors. This is constructor 1 and this is constructor 2. So we also have one destructor to show us. Then we now create a method. These are the behaviors now. We talk about function the last class, please. You have not. Let's go there. These functions get the speed. Get speed of this function. Create function or method to get speed. It's also a public. The function get speed is public, and then apply break as well. Void. Apply break. It does not return anything. Just apply it and stop. Then remember we once said that our int main must what? This is not returning feed now. I'm going to include it in the document. I'm going to correct those errors in the document before I upload it. Then you can see that we can now create the instance. This class now, we have the vehicle instance. This C1 and C2, they are not they are the instance of the object. We have the class name. This is now the object, instance of object. This C1 and C2, they are now instance of the object. Then we will come to this. There are different ways of creating this, of creating an instance of the object. I'm going to be showing us as well. Also, there's also should be a return here statement to return 0 or 1 or any integer value. Now let's move into what's called objects. Objects is an instance of a class, while a class serves as a blueprint of the template or templates for creating objects. Objects are actual instance of that class in the memory. You know, all the variable we declare int s is equal to 12, int aa is equal to b float, salary is equal to this and that. They are all stored in the RAM. But by the time we also create an object, we create what they are also stored in the RAM as well. Then we also have our object here. This is our object v1. This is another means of creating an object. We created it. You can also create it this way as well. Also create it in this form, or you just create it this way, and you now put the value inside here, inside this angle. I'm going to be showing us as well. Now you see v1 and v2. v1 is an object of the vehicle, and v2 is the instance of the object. Now you see we have v1 here, we have it here. Now you see v1 and v2 is object, instance of the object variable. All right, now let's go to the static class. Precisely, in Huobi precisely, we can simulate a static class by making all members, both data and functions, static. This means that the class cannot be what? Instantiated. That means you cannot create it this way. This is what we call instantiation. Cannot create it in this form. Cannot create it in this form. That is the reason why you cannot create it. Once we make them static, or no, in Java, it's well handled in Java, but in our C++, we have to make that the constructor of that class to be to be private, so that we will be able to instantiate it. So there will be an error in it. Let's see example below. We have a static class demo called demo. We also have static data members. For example, though we don't put static in front of class here, but all the data member or mere inside it, we put static in front of them. Like this, we create a variable of int member, static member. This does not make. This is just the same thing as maybe you declare something as s or y. It's just a name. This is just a name. So, but the static here change the meaning of this variable. The static and the data type at the back change what this variable represents. So then we also have the method as well. So the instance value, when you create the instance, you will be able to create all the instance variable for this. You will be able to do that. Then we also have private constructor to prevent instantiation. Then we have this a private constructor now. Then we have it here. We now call it here. We use the name. We create this instance static class here, but static member. We invoke our static class demo. It should be classic class demo. Static class demo. I'm using LaTeX to write my documents. Okay? So static class demo, and we assign it 0 here. Then we now assign 70. You can see static 70 is this. You can also change the value. So we display our value is displayed 70 here. So we're going to write it so to prevent error. I'm going to write this. But now let's see how is static class different from the normal class. Our normal class here, our normal class that we have here. How is it different? Let's see some table here before. Can you see one feature is instance creation? Can be instantiated, multiple objects can be created. Multiple objects can be created in the ordinary class, in our normal class. In the static class, cannot be instantiated. No object can be created in it. As this, we cannot create our v1, v2 that we saw up here. You cannot create them. Is the object of the class, the instance of the object. So the root instance of object, you can use it to create anything you want to create. Then you can have both instance, not static and static members. So this one can have, even inside it, you can still have sorry, you can still have even a static class inside a static member inside a non-static class member as well. You can see that all instance member are accessed through objects. Static member are accessed through claim class name or object. Yes, we are going to be accessing them like our class demo. We are able to access them through this. If you want to access this now, you have to come through the use of this. Can you see? You want to access it now? I will assign 70 to it. So assign 70 to it. Okay, good. Then we now move to this. Can have both. This can have both instance and instance. Okay, we have left the place. All members are accessed through the class name. We use the class name to access them. Constructor can have public, protected, and private constructors. So you can have public, protected, and private constructors. We're going to be seeing them in use case in the future. So a constructor are private to prevent instantiation. That's why we put private here in this. What is it here? Can you see? Private constructor to prevent instantiation. So we prevent instantiation here. And then the use case. Use when objects with individual state are needed. You want to need objects with individual state. There may be one object. Your classes have different functions. The functions, each function to be performed from each individual is quite different. So we also need to create an instance for each class, unlike our static class as well. Okay, I don't want this video to be too long. So in the next class, we're going to begin the coding. So thank you very much. Please subscribe. I'm going to make the corrections. I'm going to link the code below. Thank you very much. Please share the slide to your friends. Have a wonderful day. God bless you.